Hello students, this is Mr. Woolsey, and in this video we're going to be looking at the objective on scientific notation. Now, problem number 1 asks us to write this number in scientific notation. Now remember that scientific notation always has some number times 10 to some exponent. Okay? So when we write a number in scientific notation, all we really need to do is figure out what number goes here and what exponent goes up here. So first of all, the number that is out front is going to be 7.95. Now I know that because we have the 795 at the very front of the number. Those are the only non-zero digits in the entire number. Now I put the decimal point right here because scientific notation always requires just one digit to the left of the decimal point. So 7.95 times 10 to what power? Now, the way to figure out what exponent goes up here is we first imagine that the original number had a decimal point right here at the very end. Now, how many times did I have to move the decimal point to make it go right here? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I moved 10 places to the left. Therefore, 10, positive 10, is the exponent on the big 10. Now, I know that this is a positive 10 as opposed to a negative 10 because this number is gigantic. It is much, much bigger than 1. If it's bigger than 1, big number, that means we have a positive exponent. Okay? So let me just write this out a little bit more clearly. 7.95 times 10 to the 10th power. That is the number written in scientific notation. Alright, let's take a look at number 2 now. Now again, we're going to have a number out front of a times 10 to the something power. Now the number out front is going to be 4.05. Notice that I kept a 0 in between the 4 and the 5, and there's only one digit to the left of the decimal place. So 4.05 times 10 to the what power? Well, here's where I put my decimal point. How many places did I have to move to the right? 1, 2, 3, 4, 5, 6, 7, 8. I had to move 8 places to the right. Now, this number is much, much smaller than 1. So we're going to have a negative exponent. The negative exponent tells us that we move the decimal point to the right as opposed to the left. Okay? So that is the number written in scientific notation. Now, up here, for questions number 3 and 4, we are asked to write a number that's given in scientific notation and write it in standard notation. All that means is write it out completely. So 8.4 times 10 to the negative 6. Let's see. I know that there's going to be an 8.4 somewhere in the number. The question is, are my zeros on the left side, like over here, or are my zeros on the right side, like over here? Well, the exponent is negative, which means this number is really, really tiny. It's less than 1, so I'm going to have zeros to the left side. Question is, how many zeros? Well, my decimal point started between the 8 and the 4. So how many times am I going to have to move my decimal point over to the left in order to get all my zeros? Well, 6 times. So 1, 2, 3, 4, 5, 6. Plop down a decimal point. Now there's going to be a 0 in front of the decimal point. That just makes it clear that there is a decimal point there. So 0.00000084. There we go. That is it. We moved 6 places, and this is the number in standard notation. Now let's do the same exact thing with number 4. We know that there's going to be a 952 somewhere in the number. Now the exponent is positive, so the number is going to be much bigger than 1, so the zeros are going to be all on the right side, just like they were over here. Now, the decimal point starts between the 9 and the 5, and I need to move 11 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is my invisible decimal point at the end of the number. So there's going to be a 0 here, 0, 0, 0, 0, 0, 0, 0. How many zeros is that? 3, 6. Wait, I don't think I did enough. Nope, I did this wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I should have one more. There we go. One more 0. Okay, so there's going to be a comma here, comma here, comma here. That's getting confusing, but you get the idea. There should be 4, 5, 6, 7, 8, 9 zeros in total. So let me just write this out a little bit cleaner. 952 billion looks to be the number. Okay, 9 zeros, and I move the decimal point 11 times from in between the 9 and the 5. Okay, so let's move on to question number 5. Simplify each expression, writing your answer in scientific notation. Now these questions are deceptively difficult. They're actually very, very easy. All you really have to do is plug these into your calculator. The problem though is that you need to be able to plug it into your calculator correctly. So first of all, this one right here, first of all we need to write all of the parentheses. So 6 times 10 to the 4th power, then get into a new set of parentheses, times 4.8 times 10 to the 2nd power, enter, 2.88 E7. Now remember that the E just stands for times 10 to the. So 2.88 times 10 to the 7th power. This is literally all you have to do for these problems. Just plug them into your calculator. Just make sure to do it correctly. So let's do the next one here. 0.5 times, in parentheses, 3.2 times 10 to the negative 6th power, end parentheses, times 7 times 10 to the 4th power, end parentheses. Oops, I didn't mean to have that many parentheses. Okay, now things are getting crazy. Let's see here. Just want once. There we go. And then outside of this parentheses, we are going to square. We are going to square just what's in the second set of parentheses. Oops. Caret 2. There we go. So this now looks like what we have here. Press enter. 7,840. 7,840. Okay? That's all you have to do for that one. Now, the last one, we are asked to do a division problem. And so we need to be careful. We need to make sure to wrap everything in the top in parentheses and everything in the bottom in parentheses. Okay? So, in parentheses, 1.5 times 10 to the 7th power. Get out of the parentheses, divide. In parentheses again, 5 times 10 to the negative 2nd power. Oops, threw in a 0. There we go. Enter. 3e8. All that means is 3 times 10 to the 8th power. Okay? Again, the most important thing here for this division problem was to wrap everything in the top and everything in the bottom in separate sets of parentheses. Alright, let's move on to number 8. Uh-oh, word problems. I hate word problems. The sun has a radius of 7 times 10 to the 8 meters and a mass of 2 times 10 to the 30 kilograms. Now, we are given a formula. Use the formula for the volume of a sphere, V equals 4 over 3 times pi times r cubed, to calculate the volume of the sun. Use pi equals 3.14. Okay, so let's calculate the volume of the sun. We're given a formula. Volume equals 4 over 3 times pi. We're told to use 3.14. times r cubed, the radius cubed. So we're going to have the radius inside of parentheses. Again, parentheses are super important here. 7 times 10 to the 8. And then cube that inside of parentheses. Now this is literally all you have to do next to plug it into the calculator correctly. So 4 divided by 3 times 3.14 times inside of parentheses 7 times 10 to the 8. Get out of the parentheses and then cube it. Okay, so now that looks identical to what we have here. Oh, sorry, that's in a shadow. Enter. Okay, let's take a look at this number. 1.436. We can actually write the whole thing out if we want to. 1.436. Actually, I'm just going to round that. 1.436 times 10 to the 27th power. Now this is volume, and our radius was given in meters, so if you wanted to, this is meters cubed. It is cubic meters. But really the only thing we need to box is that right there, that gigantic number. Now, part B. Use this formula, density equals mass divided by volume, to calculate the density of the sun. Compare this to the density of water. So density is equal to the mass we were given up here is 2 times 10 to the 30, and we are dividing that by volume, which is what we just found, 1.436 times 10 to the 27. Now what is this equal to? Again, let's use our calculator, and again, let's be super careful. We need to wrap everything in the top inside of parentheses, and everything in the bottom inside a separate set of parentheses. So parentheses, 2 times 10 to the 30 divided by, inside of parentheses, 1.436 times 10 to the 27th power. Here we go. 139, I'm going to round this, 3. Okay, now the units. Our mass had units of kilograms, and our volume had units of meters cubed, or m to the 3rd. Okay, that's our density. And then let's compare this density to the density of water, 1,000. So look, it looks like the sun is slightly more dense than water. Not too much more dense though, which is kind of cool. The sun is actually made mostly of gas. A lot of that gas is really, really dense in the middle, because that's how nuclear fusion happens. You need really, really high density and pressure and temperature. But for the most part, the sun is not very dense at all. It's made of gas, and that's what makes this number somewhat reasonably approaching the value of water. So I hope this video helped you with scientific notation. Get ready to retake your objective.